My name is Andrei, and I'm here to talk about strategic SRE AI agents. But it's not to be worried about how I used or how I build my AI SRE agent. It's more about how you can build your AI SRE agent and how to do that. What is AI SRE? AI SRE is a hot topic. It's something that emerged recently and it is very popular. Everyone is doing AI SREs. It's how you automate the SRE operations with agentic AI. It sounds very familiar because we used to be automating SRE multiple times in the history already. The common themes that are used in AI SRE is problem discovery, how you detect the problems with AI, root cause analysis, how you find the problem causes in your system with AI, to analyze the raw data, to cover knowledge gap when you don't know how exactly to write that kubectl command or piece of the YAML. These are the things that people use with AI SRE. It did not happen instantly. There is some history to it. It was starting around 2020 where ML Ops was coming with traditional ML. And as we already know, ML Ops did not really overtake the majority of everything. Not sure how it will be with AI SRE. Then it went into LLM early adoption era when we were all copy-pasting into ChatGPT. We still copy-paste into ChatGPT, but something more organized happens around with the agents. Now it's the era of automated agentic SRE. We are actively building it. We are actively using those. And it seems that it is going into area of multi-agents interacting and actively fixing things, not only suggesting, but actually making decision in a fully automated fashions. There are some open source players in the area. There is K8s GPT, very old one, interesting CLI style direct connection to your Kubernetes cluster. There's kubectl AI that Google has brought as the plugin into your kubectl. Everything you see, it's in CLI. The K8s recently appeared also building the things around agentic SRE. The common theme among them is that it's mostly direct access to Kubernetes cluster, CLI usage, highly text heavy, you type, you read, you type, you read. Cloud vendors also coming up with their agentic solutions. And common theme there is that the cloud providers, they usually provide it's like everything is limited to their universe. They don't recognize that anything exists beyond it. They only serve them just as an additional channel. APM vendors, they also want to participate in that, and just like cloud providers, they also tend to find solutions with what they have. It's the way to interact with their data of APM, metrics, the data that they collect, alerts. And it feels like the sprawl of AI agents is everywhere. When I was preparing for this presentation, in the last 3 days, I got at least 2 notifications in the channel where my company tracks the AI SREs, because we track competition. It's like at least 2 new things discovered. And each week it comes and comes, varying from the promise of contact us, we'll tell you more, all the way to different solutions, very obscure. Not many of them put everything real out there, but the feeling, it creates the vibe on the market that everyone wants to have something with AI SRE if you are a player of that area. And I have a feeling that it happens because the LLM has a big problem. It has a deceiving ease of creating anything with it. You put the input, it puts meaningful output. That's great. And it feels so easy. It's the next business idea of doing that. I personally very annoyed with the motion of chat interface is that thing. You take the LLM, you just create the chat interface. Now my application is AI ready. I can check the box. I can create the marketing gimmick out of it. I'm very annoyed by that because I really believe that you should invest into different use cases and interfaces, not only the chat interface. And a lot of mistake by people coming into agentic AI is that they have an assumption that thing is infinitely intelligent. So they perceive it as the general AI, and they start to interact with it with this assumption. No, it's just a complicated machinery, and experts in LLMs, they would tell you that no, there's no intelligence. There's neural network. It's just slightly beyond our comprehension how complex is it, but it's still more or less if else with the coefficients. My company has built our own flavor of AI SRE, and we learned many interesting things along the way. And I'm building that AI SRE, found some cool insights. And instead of just showing you how that AI SRE functions, I would like to share the insight of building it. Because what I really believe in is education. If the whole market will be doing things better, tomorrow the AI SRE will become much better reality, maybe less chatty, less text reading and text writing, and more value delivered. So these are my view on how you build AI. First concept that I found the most beneficial for understanding it. Think of LLM having cognitive capacity, just like the intelligence. It has some cognitive capacity like all of us. So it spends some part of that cognitive capacity to understand what is the input into it. It spends some part of that cognitive capacity to generate the output requested from it. And then the remainder is for decision making and actually doing the intelligence. The clearest and the most direct takeaway from there is if you give a dumb task that could be done by normal old school programming, you spend that cognitive capacity for something wrong, you spend it in vain. Don't do that. Take away everything deterministic out of it and only leave the intelligent, complicated tasks for it. Simple example, and very, for me, it's, I don't do it this way, but for even among my colleagues, I see that a lot. People are lazy, right? So they take the CSV of Kubernetes operation, something statistics, give it to LLMs and ask it to figure it out. And please generate me also this huge nested JSON that my web UI would be showing right away. I don't want to spend time coding that and transforming it. You are the smart one. So LLM does that. And you can make it work for your particular case. What happens with it is it's not scalable. If you want to make that case working for many examples of inputs and outputs, you would see that the percent of hallucination and mistakes is huge. What do you do instead? This is where we are slightly jumping forward, but for the illustration. What do you do instead? Speak with plain language to it. Because it was trained on the plain language primarily, CSV is not the input to LLM. It's somewhere through the inputs, it somewhere gets that CSV, it gets JSON, but the primary source of the input to LLM is plain language. Transform your inputs into the plain language, it would spend much less cognitive capacity understanding that. Then make it generate outputs in the plain language. And it would be making much more meaningful conclusions if you ask to generate in plain English. And then when it did all of that, then ask it to look back and transform it into JSON. And then it would do just that. It would look back and transform the information. It would not hallucinate, trying at the same time generate complicated JSON, make sense of CSV, and God only knows what happens to those coefficients in the LLM doing so. If we take a step back and now go through this process in a more organized fashion, how SRE agent or any LLM agent is built. It's built in a simple fashion. There is this loop of enriching the context. The context is a precious thing because that's the input to LLM. And it's driven by system prompt given to it, input messages given to it, the data sources that you give to enrich the context in an automated fashion, and some output you expect from it. Now let's look into some of these pieces in detail. First, it's the system prompt. Again, humans are lazy, so most of the system prompts I saw is, you are SRE, you are doing this, that's it. The context has been set. The system prompt is a critical thing. LLM pays a lot of attention into it. So if you invest into it, it would work much more better. The formula that we figured for RTM anytime we create a system prompt, we put into it these components. The role, explain which role it has to impersonate, because it was trained on the whole internet, and you don't want it to be considering itself even at slightest chance to be a teacher of the dance classes of ballet. You want it to be really narrow. So be clear at the role impersonation. Then the circumstances can be different. It's an SRE agent, right? But SRE can be firefighting. SRE can be strategically looking at the infra. SRE can be troubleshooting the pod. SRE can be figuring out optimal configuration. The circumstances differ, so you need to clarify that, and it also helps the LLM to focus. This is all about focusing LLM, so it forgets about dance classes, it forgets about Australian tribes, it thinks about SRE. The goal, you should clearly explain it where it needs to get. Otherwise, if you're ambiguous, it will be getting to the random places. Again, you can, through the chat, you can make it to give you a result in one place. But if we are talking about automating something for many people in many different situations, you need predictability and control, which LLM do not have by their nature. You have to make it. So the goal should be clear, what it is expected to do, what it is doing. Provide specific examples. It's great to give it example of how the result looks like, because again, the ambiguity is huge. It's been trained on all of the craziness of the internet. And limitations. Sometimes it's easier than explaining that it should be like this, and also like this, and also like this. Instead of all of those long explanations, it's easier to explain that you do not do that. You do not use kubectl to generate me the example comments, because I don't have kubectl at my hand. I don't have direct access to Kubernetes, but I have something else. Or you say, you do not use Helm because I don't have Helm. Any kind of limitation really helps it to stop producing garbage, because LLM likes to produce the garbage. Stay within public domain. It connects to the system prompt a lot, and we had our own story of having this problem. Is if you bring it custom concepts, something innovative, not existing in the internet, it would most likely be confused, hallucinate, and you will not get desired result. You have to translate what you have, either explain it elaborately or translate it and stay within public domain. For example, in our case, we had the custom events, the deployment events that we create in the Kubernetes cluster. So when we started to feed this data, assuming it would understand it's an event, it's a deployment event, no. It started to really confuse and mix things. We had to change the presentation instead of custom events into really thing of its own, well displayed, well explained. Now, the deterministic part of the agent, there is this assumption that you just take LLM, put inputs into it, and that's it. No, actually, the most beneficial thing that you would do to your SRE agent is surround it with deterministic circumstances. Instead of giving it very free things, instead of asking it to discover the problem, you need to put it into circumstances. For example, instead of giving it a cluster and saying, here's your cluster, it has a problem, and find it, please, like many open source players do. Instead of that, you say, here's the pod in this specific namespace, and it has the problem. And I claim that. Now your goal is to find the root cause of that problem. It's much more directive, much more strong statement. Instead of find the problem, you say the problem is there. I detected it through some other ways, through my monitoring system. Now we talk about that much more narrow space. And LLM outperforms others when you give it such circumstances. Finding those use cases is hard. Finding those specific places is hard. In our company, we use it for logs analysis. It's very clear situation when there is the log, please help me understand it. That's it. There's the pod surrounding it, all of it. Root cause analysis of particular failures in the system. We have those deterministically detected, and now LLM analyzes that. And then we also use it to recommend some smarter ways of best practice violations. Inputs. Again, naive guys all around the market say, whoa, which inputs? We'll just pass the text message of the user, and that's it. This is my input. No. another half of the guys on the market starts to put everything they have into the inputs. Here's my full YAML of the thing. Here are the logs for the last 24 hours. Here are all of the surrounding things. And LLMs are such a tricky beast. When you give it not enough context, it starts to, not enough inputs, it starts to hallucinate inputs. In one of the early versions of this cloud AI that we built, we had a problem when you are giving very small pod that is broken and has no diagnostic information. What LLM was outputting, it was saying, oh, I see there's no this pod existing and there's small diagnostic information, but let's repeat the exercise with the existing pod. And it was generating the inputs of non-existing pod for itself and continuing the conversation by itself with itself. Because why not? It's such an incomplete input. What works the best for us is that if you set that context, if you created for LLM the impression of a very clear goal, then the only thing you need is just small minimum to spark its intelligence. It is smart enough to do right after it. In our case, when you want to root cause analysis of something, the thing that is enough as an input is just the problematic pod is this name and this namespace. That's it. It already knows it's an SRE. It already knows that it's doing root cause analysis. It knows what's the tools to use. It goes forward and does the thing better than some additional explanation. Which algorithms should we use in that agents? So one of the things that I see experimented on the market, and we also experimented that early, is the approaches, the vision of LLM. You remember those pictures? There is the Kubernetes troubleshooting chart coming popular on LinkedIn, where you have this really nicely looking guide of how you troubleshoot things and find the root causes, right? And we tried that, doesn't really work, and when it works slowly, because instead of being smart and jumping from left side to the right side in one hop, it has to go through all of the excessive things. No, humans do not work like that. Smart SRE jumps through this chart effectively, efficiently, and quickly. So it doesn't work. We tried in multiple variants with even more complex and smart diagrams. What you can actually do good to direct LLM into the right algorithm is really nudge it. Let's imagine the deployment is broken. Here's the describe of it. The human comes and says, let's say system prompt explained that it's an SRE. The LLM says, okay, I see that the status is crash loop backoff, so let me see the logs of the container. And the tooling mechanism brings the container logs. And then LLM says, okay, in the logs, I see the message about missing the file. Let's see the config map. And it brings the config map. And then it continues like that until it finds the root cause and gives you the result. Looks good? Yes. But this is fake. This was not generated, this like one step in this case, was not done by LLM. It was deterministically injected to show how LLM should behave. And this is how you nudge it into right direction and show like, it's like you told me that you would be explaining it. So it would start in the next message, it would be keeping the style because it assumes this is how it behaved. And it would be keeping the style and doing it. So instead of system prompt showing elaborately how it needs to behave, you can lead by example. You can inject the history, and that works great. Outputs. We already showed that you need to only output deterministic JSON's complicated data when it's ready from the reasoning perspective. The intermediate results, they may be, if you make LLM through agentic loops, the intermediate chat contains too much information of it, it can lead to loss of the focus and it going somewhere else. If each of the message enforces and reinforces the goal and keeps the goal, it keeps the focus and reaches the desired result much more in a guaranteed fashion. LLMs will always confuse the structured outputs, generated JSONs, and we have to have those to have the APIs on top of the LLMs. So what we learned is that it's hard to restart all process from the beginning. It's much better to ask LLM to correct itself, keep the result, and spend 10 seconds instead of more minutes. And tools and data sources. The best thing you can do is parallel data querying. It saves a lot of time because the modern agents, they need a lot of data to do their decision making. And the parallel data querying is the great saver. It can half the time you spend in loops, and most of the time LLM can say all of the information that it needs ahead of the loops. Would save you a lot of time. You have to clean the information that you give to LLM because the context window is such a small thing. You will need to decide who to sacrifice in those YAMLs. For example, if you take YAML of some resource, you could find Kubernetes last applied manifest or something. It puts everything that was fed as an input there. You can find a managed fields something. So don't be lazy. You'll have to do the cleanups on your data and also the presentation of that data into human understandable form so LLM makes sense of it and doesn't lose the focus. What we actually did, and this is about the tools, interesting story, is that we did not use the LLM native tool calling, the API tools, none of those concepts initially. What we did in the beginning is we created the pseudo CLI tool. So we gave LLM impression that it has some custom CLI tool, and it could call it to get the data. That tool was called load YAML, pod namespace name of the pod. Worked nicely. The universe of it was quite small with that tool, but sometimes it did not work well because it assumed in 5 iterations it felt like it has kubectl and started to assume kubectl that we did not offer to it. The later version, we also felt the limitation with parameters. We created pseudo DB API impression for LLM, so it could use some sort of strange API to call with more flexibility in parameters and more paths to be used. Again, worked great. And then recently, we wanted to finally migrate off these custom things into standard Bedrock tool calling where there's JSON and concept of tools in the API. And we used framework called Agno. It's an open source with that. And guess what? The old pseudo tools outperformed it. It was smarter and much, much better when the tool calling was integral part of the chat. So we, in the middle of that experiment, we sat and said, what do we do? Do we keep the old one, it was painful to develop because we had to reinvent the wheel. So what do we do? And we had to put special effort to overcome that problem. But that's the lesson learned for us, that if you put things into main chat and not on the side regarding tool calling, it gets much, much more strength than leaving it to that implicit API, because the tool calling is really implicit, the declaration of the tools implicit and on the side in the API. And it could be much stronger if you make it part of the main chat. Going to production, I could tell the whole separate talk about what does it mean to take the agent and then get it into production. I will just list here these bullet points. There's a lot of interesting stories behind all of them. You need to think of API layer and scaling those. How do you run that at scale and in parallel? How you store those, the sessions, the outputs, so the user comes and sees results tomorrow that happened yesterday. The user interface and UX, how you present that, not the chat. I'm talking about deterministically happening things, not the chat experience. Chat experience is already solved and it's answered. The root cause analysis results, for example, how do you see those? How do you authenticate your users and make sure that they do not see the data that they're not supposed to use? You need to create a process when LLM do not have access and do not try to troubleshoot from the perspective that user would not be able to reproduce. Or you need to hide all of the intermediary steps from the user, otherwise you have the security leak. You need to monitor your system because the latency is jumpy with LLMs. You need to troubleshoot, go back and recognize the problems and do all of that. And you need to gather the feedback, and people are not willing to give you any feedback because they are lazy. They don't even want to put the thumbs up, thumbs down button. You need to be creative to understand it worked or not. Whole separate story, I'm sorry, but I would like to spend time on other things. Now, we completed it. We deployed it. It works. It looks good. How to make it great? So we created the very narrow use case, clear problem statement, a lot of relevant data got into the context. LLM has explained the observations and concluded on the root cause of the problem, let's say. How to make it better? Any suggestions? That's good and advanced, but my point is different. Now it's time for chat. Because LLM would be making mistakes, it can be outputting the results, those results of it, in a confusing way for a particular person. So now it's time for chat to shine. So the chat now becomes very different experience. And all the way I dislike the chat experience, in these circumstances, it's really great because the human do not have to type a lot now. It needs to only clarify the things and continue troubleshooting maybe for the deeper things. What you say is much more advanced and much more on top of what we talk. It's great, but my point is smaller and more particular. But this is important. When you solve the particular use case with your LLM agent, if you don't let the open ending to continue into the chat for human, it would be incomplete for people. They need to have the way to continue and clarify and simplify and maybe get it to steer it to some other side. How much time do I have? None? Let's sacrifice the lunch. Keeping the momentum. Now, when you develop that thing once, the problem is you want it to evolve. And each iteration, you want to make sure you do the progress. And LLMs are non-deterministic. You want to make a change to system prompt that would affect everyone and everything. How do you make sure that it's better and not worse? There is a separate set of strategies for that. One, you can just look at the results. You can put internal lab, run it many times, and look at the results as a human. Your brain is much better than LLM, so you will quickly figure out a pattern. It's expensive, but if you don't have any big production environment, you'll have to rely on your human brain. Works fine. Second thing, comparison. When you as human, when you look at one thing and one apple, and I ask you to qualify it on the scale 1 to 5, and then I remove it and I put the second apple, and I ask it to qualify, you will give 5 stars to both. But when I give you both at once, and I ask to say which one is better, you can tell which one is better. So the experience of comparing it is much better analysis strategy. And we have our CTO who does that public comparison to competitors, versions of LLMs in his LinkedIn a lot. And we've been doing that for over a year. And it's very insightful to see how different versions of Amazon, Llama, Claude, ChatGPT behave on the same task and same circumstances and compare them side by side. Another strategy, back-to-back testing. Run everything twice at the same time in parallel and change the algorithm, the system prompt, and then you can see that the side-by-side comparison, who's better, and quickly figure out, well, by looking over time, who is better. More advanced strategy, employ LLM to do the scoring and comparison. They can do that, again, as a human. If you give it 2 things at once, it would be much better than just giving one thing and ask to evaluate, because it evaluates everything roughly the same. Another important thing, if you give it guidance on evaluation, it would be producing numbers in a much better fashion. And this is the screenshot of revision 14. This is how many iterations, and it lasted for 2 months. It took me to make the Agno version of LLM agent of ours to beat the old one with embedded tool calling. So 14 iterations, and we finally got 3% better. And we got this evaluation. It's really custom to our case, but it's a tool that saves a lot of time. You can really experiment. You change it, you put experiment out. In 2 days, you see the results. It builds the report for you. You can even drill down into individual tool calling and see that some tools, it's like listing resources more in old version, but the YAMLs are, or what is it? Something, let's had to cut the screenshot. The parallel tool calling, the old version of built-in tool calling into chat was perfect at parallel tool calling. You can see that on this slide graph here. The peak was here. The new version was much more one at a time and spending so much time. And I had to do special efforts to even reach this state because it was disobedient and it is still a problem. And the old one, somehow it's such a magical scaling of parallel tool calling. But we still went the Agno way because we need to scale the team. Another strategy, injected failures benchmark. If you can create a set of failures, fake failures that you can use as reproducible set of test cases for your, let's say, root cause analysis, is much, much better because you can have some sort of a test bed and compare results in a much more predictable fashion. You don't need to wait for 2 days to accumulate the statistics from productions. That's served really well for us. Finally, this is something that I wanted to say in the beginning, but you saw many screenshots of things we have in our system. But this is not production. This is internal lab. So we really invested to create a separate application of our own that creates the place where you go and by click of a button, you have a problem injected into the Kubernetes cluster if you want, the troubleshooting session if you want, the chat session if you want. Anything that you do, you can continue asking LLM on particular root cause analysis session to ask, why didn't you go and look at the logs of that particular pod? What was the reasoning? And then you decide how you change system prompt to avoid that, for example. So really invest into it. We had it from the very beginning. That's the most valuable thing that helped us to reach the state where we are as of today. To summarize, AI SRE is a great enabler. I have a feeling that there is a bubble around that inflates. And when it pops or deflates, will be at a funny stage, but the AI SRE will persist because it gives the real value proven by our customers. Naive approaches, only chat interface, a lot of text typing, a lot of text reading, the results will be there. They will be mediocre. If you want superior results, use deterministic context, much more focus for LLM, and all of the smart things that I showed you that you can use. Invest into your internal development of AI lab, and you will feel much more comfortable and in control when you are building your AI SRE. And the great new things will be ahead of us with these improvements. Thank you.
Thank you very much.